Hi, my name is Nick Bowen. I am a product manager for Benetech and Bookshare. This is me doing my best Michael Scott impersonation, if anybody's a Office fan. No? So, I'm known for two things at Benetech: overstating the importance of things and overhyping products. So, bear with me. But I do honestly believe what I'm about to show you is something that could revolutionize the accessible industry. So, we're going to talk about math. Math in accessibility. So let's talk about where we currently are. It's bad. So, a lot of times the equations are just images. Student will come up there, read through a book, and it'll go, solve the following equations. 1, image. Great. 2, image. That's helpful. I have a story of a friend who's a teacher. And so, forgive me, it's a story of a story, but she said she had this one student who's a little bit younger, and the student had this problem that said, add the following 2-digit numbers. And the teacher said, is it reading to you? And the student said, yeah. And she said, oh, that's amazing. Okay. Do you need something to help show you work, help to add? And the student looked at her really confused and said, no. And she goes, okay, well, what's the sum? And the student goes, 6. Really happy. And the teacher's looking at the book, and the first number is like 63. The second number is like 24. For whatever reason, the screen reader read the first number as 1. And the second number was 2, and the third number was 3. So, 6. Not helpful. There's also this scenario where the images the equations just aren't there. They say removed. This is unfortunately very, very common. But with Benetech, we recognize the problem isn't necessarily making math accessible. We know how to do that. MathML has been around for a little while. There's systems out there that can read MathML. There's things out there. The problem is the scale. Every math textbook has a ton of images. I picked 3. These are 3 random math books in the Bookshare collection. They have over 6,000 images in them. Over 12,000 images for this Glencoe Algebra 2 book. And I saw that one, I went, oh, that must be really high. That can't be normal. And I grabbed the third one and had even more images, almost 14,000 images. Trying to spend the time to remediate 14,000 images means the student will never get the book. And that's what's painful. And just to note, on Bookshare's side, we have over 30,000 books in our math category. So if you do the math of how many images there might be per book and how many books that we have, it becomes insurmountable. But part of this, not all the images are equations. These are just some random images that I pulled out of a math book, again, from Bookshare. There's the Mona Lisa. Why is the Mona Lisa in the math book? I don't know. I'm sure there's a real reason for it. But then there's the graph and calculator outputs, there's graphs, there's plots, there's the enter icon. Again, I don't know why that was necessary to put in a math book, but I'm sure there's a real reason for it. These things, we can't send them off to a tool that automates MathML because the tool won't know what it's doing. So when I say scale, this is what I mean. There's just too much for human remediation. We will never get that book to the student. If we send all these items out to the existing tools. There are tools today that you can send math equations to that will turn them into MathML. We can't just send every image from a book to that tool because it'll cost far too much, and it's 50% of the images aren't equations, so they're useless. In those examples that I gave before, the book that had 14,000 images, we ran it through, we checked, there's about 6,000 math equations. The other, 60%, the tool would have blown up and not known what to do. But they still would have cost Bookshare immensely for attempting it. So, what if we had something that we could classify an image automatically that says this one's have math, this one doesn't. This one has math, this one doesn't. What if, because one of the other things we learned is a lot of these automated tools have problems with the image quality that comes in these books. The image quality is relatively low sometimes. So what if we could automate the enhancement of those images before we send it to the tool? That way the tool becomes more accurate. And then, more importantly than anything else, what if we could do this at scale for a fraction of the cost? So we did. We're introducing today Math Detective. Math Detective is our machine learning tool that is built on Amazon's serverless infrastructure, meaning we can scale it up to demand immediately. And it classifies images. It says these images have math, these images don't. The images that do have math, we automatically send them out to a tool, turn them into MathML and LaTeX, and ship them back to whomever's asking. So at a high level, how does this work? When we get the image in, we do some enhancements. We turn it into a black and white image because we found that the OCR tools do far better with black and white images. We increase the resolution and do some interpolation in there so that way the numbers become more distinct. And then we run it through our classifier. For those that know machine learning, we use an existing machine learning model called MobileNet version 1. It's on purpose. MobileNet was designed for mobile devices. It was designed for phones. It was designed for things that don't have a lot of power behind them. And that's important because we're sending this out to the Amazon serverless environment. We need it to be very, very lightweight. So it does the classification. It says, these groups here, these groups of images are math equations, the rest of these ignore them. The ones that are math equations, we send them off to our OCR tool, turns them into MathML, and then we ship them back to whomever asked us. This is an API, meaning it can be integrated into any tool. So I figured, why just show? Let's try a live demo. Pray for me. So this is a website that will be going live very soon. This is our Math Detective website. And on here is our try. I'm going to select an image. So I'm going to refresh first. Yes. Select an image. Here's some very basic math equations. That'll help. Let's pick this image. Now what it's doing is it's sending that image through our classifier. It's saying, is this an equation, is it not? And if it is an equation, then it'll bring back here momentarily the MathML. Please. Here we go. So in here we have the rendered MathML. Wow. The rendered MathML that we pulled up from our tool. Underneath that is the full MathML of the equation. I was trying to turn it off. So underneath this, you'll find two scores. The two scores are the important ones. It's confidence that it's math, and it's the confidence in the MathML part. The confidence in the math is our tool saying, yes, we are 90% sure that this is math. In fact, this one's 99.9% sure that this is math. The one underneath that is our translation accuracy. So we are 99.9% sure that we actually rendered this equation correctly. Now what's fun is we can select something else. So let's say I want one of these random plots and submit. Now this is going to come back and say, nope, we're 3% sure this is math. In other words, it's not math. So we didn't send this out to anybody. Now, the important thing I said about this is it scales, and it scales in a cost-effective manner. Math books use the same images over and over and over. So the other thing we did is we cached. We took a unique identifier for each of these images and we cached them. So the next time this image gets submitted, we don't even send it off to the MathML OCR engine that we use. We just give back what we already got back the first time, saving us immense amounts of money per math equation. Hey, the live demo worked. Thank you. So let's talk about building this engine. The first goal is that scalability. We've built this on, like I said, on the Amazon serverless infrastructure, meaning it will scale up to the needs. There will never be a server outage. We will never be busy. It will just work. Accuracy. So we started with MobileNet version 1. In our current training model, we're at 98% accuracy in identifying math equations from not math equations according to our own training information. We're going to improve it from there, but that's a great start. And of course, the ease of integration. This is built as an API. This is something that anybody can put into any of their applications anywhere, not just Bookshare. This is open for any partner that might have a scenario where they're presenting images as math equations. So I did want to take one sidestep and talk about our Born Accessible initiative, because some people might say, but Benetech does a lot of these other things. This is not saying that publishers are now free to let math equations be images. We're still working with publishers to make the math equations accessible from the get-go. This is an acknowledgement from us saying there's still going to be places where we need to remediate math, scaled remediation of math, everywhere else. So just in case there are questions about how does this work with the rest of the messages that you might hear from Bookshare and Benetech. So let's talk about how this might work. This is currently in testing on Bookshare. We will get this live so very soon. It's so exciting. When a book comes into Bookshare, if we identify that it has math equations, we're going to take all the images out of it and we're going to ship it to Math Detective. We're going to do our normal Bookshare remediation that goes through their normal pipeline all across the bottom, but the Math Detective does its magic. When we get back the Math Detective data, it's going to be MathML or LaTeX. We're going to use the MathML. Anytime that we find a math equation that has MathML, we're going to strip out the image and replace it with the MathML, immediately making the whole book math accessible. And this takes minutes to do the whole book. So this is the part that actually makes me excited. That was exciting. I love that we're finally getting to a pot where we can do scaled math remediation. But what we did is we created something that can classify an image and send it off to a tool that remediates that image. Why are we limiting it to just math? What's next? We could do charts. We could do tables. We could do basic images. What if, how many times do you see in a textbook an arrow? What if we could detect the arrow and just put alt text in it that says it's an arrow pointing left, pointing right? So that's what's next. And this is why when people say, what's the name of this product? Math Detective today? I believe it'll be Image Detective tomorrow. The idea is we can get any image coming from any book and classify it. Say, these are math equations, these are basic images, these are charts, these are tables. Take your pick. What else? Shapes, like landscapes. I don't know. We can classify them as long as we can find a tool, or if we can build a tool that remediates it. We can classify it and ship it off to that tool. That's what I think makes this really special. So this is what I mean. Math Detective can do graph descriptions, accessible tables, basic image descriptions, and so much more. I'm so very excited. So that's me. My name's Nick. Please come visit our booth if you have any questions about Math Detective, how this might fit in with your day-to-days. We're in 619. I'm so excited to see where this can go. Thank you so much for your guys' time. Yeah, any questions?